to all our friends at Airbus Defence and Space in Les Mureaux, back in France, at ESA headquarters in Paris, ESTEC and ISAC and ESRIN, all of our industrial partners as well, as we look at the spectators gearing up for the liftoff. To all of you watching on the internet, also we all hope you're enjoying the evening. We're going to cut away and let you enjoy the liftoff. You will hear the DDO call out the final 10 seconds and we'll be underway. Enjoy the liftoff, everyone.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80 et décollage VV12 Aeolus. La propulsion est nominale. La trajectoire est nominale, la propulsion du P80 est nominale.
The DDO says all is fine on board. You saw Vega take off like a shot. I'm always amazed. It took her about 3 seconds to cross my computer screen here. 3 seconds, rising like an arrow. Surprisingly fast if you're used to watching the Ariane 5 liftoff. Ariane 5, of course, raises into the air much more slowly, weighs 6 times what Vega does, carrying 4 times as much propellant. Fine shots of her rising into the light clouds. All is well on board, says the DDO. Vega weighing 138 tons at liftoff, as she lifts off from French Guiana, beginning the 12th mission in her career. They call her the light launcher at 138 tons, but I guess that's relative. The first stage is burning now. She weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant in any system that we're using today. The first stage burns its single engine for about 2 minutes before being jettisoned. Maybe we'll be able to see that as our camera is tracking Vega, because visibility is pretty good. First stage is produced in Colleferro near Rome, then delivered to the French Guiana plant here, where it's loaded with fuel and transferred to the booster integration building. You probably saw some of that on the video on the launcher campaign. And having returned with a big smile on his face, before separation, is Martin Kasper. So, how was it?
Incredible.
Tell us.
You see it, you feel it, and all the emotion that comes loose. It's great.
You're laughing.
No, it's not laughter. Yes, it's laughter, but also cry.
Did you cry? Did you shed a tear?
I did shed a tear.
That's good. What impressed you the most? The sound, the speed, the light, what?
The light was so bright. I had not expected that from such a small launcher. I saw the Galileo or the Ariane launch, but this was much brighter than I had expected.
It's like Times Square out there. You can read a newspaper. All right, very good. Come down and watch a launch, folks, if you haven't already. P80, first stage separation has come on time. The second stage is burning. We're into the second stage burn, called second stage the Z23, Z for Zefiro. Burns its solid rocket motor for 86 seconds. Avio, of course, responsible for production, integration, and testing of both second and third stages.
Et propulsion du Z23, parfaitement nominale.
Vega's launching north, going into a sun-synchronous orbit. Why do we need that sort of an orbit?
We need it for Aeolus, for the instrument, for Aladdin. We want to have a dusk-to-dawn orbit, so that we're always in the sunlight, and it's also the best way to measure the wind profile.
And the orbit is called, they have a name for it, it's ball of yarn orbit, right? Explain that to us.
It is basically, you go north to south pole while the Earth is rotating underneath of you, and this way you peel off the Earth completely.
You saw separation of the second stage. We're waiting for confirmation by the DDO of the third stage, ignition of the third stage. And there you are, right on time. And coming up next, separation of the fairing. All right on time. We can separate the fairing now because we've made it out of the atmosphere. Now, exposed to the elements, the right On the right, the round white section, that's your baby.
That's, well, the baby is the cubicle and the white part of it in total, yes.
So she needs no more protection from the atmosphere. She's getting her first taste of space.
Of space, but not the first taste of vacuum. She was tested in CSL Belgium.
Right, we have a story about that coming up. First, we're used to seeing, here's a question for you, commercial satellites, 15-year lifespan, maybe more. 3 years for Aeolus. Why is that?
Well, Aeolus is one of the Earth explorers, and it's also a technology demonstrator. And because of the small size, we have less fuel on board than the telco satellites have.
Right. So how much fuel, roughly?
We have about 266 kilograms of fuel on board for a 3-year mission. And the other thing is geostationary satellites are geostationary. They use less fuel to stay in orbit.
Now, why is that?
Because they are geostationary, so they've got...
Because they don't go round in the ball of yarn.
Exactly.
Okay, very good. Another question for you. Aeolus is riding inside the Avum, that's the upper stage. What is Aeolus doing now? I ask you because sometimes satellites are launched on internal power, sometimes they're not on internal power. There are two schools of thought, and there are advantages for both sides. What's the case today?
Well, for Aeolus, we are on internal power since about 10 minutes before launch. So we made sure that our baby is awake and running its own internal processes.
And what's the advantage to that?
The advantage is that we know that the spacecraft is on. You can also switch it on in orbit through a telecommand. But then, if you miss it, it will not go on. The disadvantage of what we're doing now is that you're on internal power, so you are draining the battery.
You're using some of that power.
Exactly.
Yeah, but I guess there's a case to be made for both sides. That's a hot debate in the space industries. As I see it, Vega means, excuse my Italian, Vettore Europeo di Generazione Avanzata, or Advanced Generation European Vehicle. The light launcher is the newest member of the Ariane family. Coming up on separation of the third stage. There you are, right on time. Confirmation from the DDO. Now what's left of the composite? On the left, the triangular bit is the Avum, triangular white bit. The gold box in the middle is what?
That's what we call the platform. So that's basically containing all the equipment to keep the satellite in the right orbit.
And you can still see the composite on the right of your screen. And, of course, the spherical, the oval, white on the bottom is the...
telescope. The telescope, which is part of the instrument, Aladdin.
Aladdin, very good. We'll have more on the instruments coming up later. We have been picked up by our downrange tracking stations. There's one here in Galileo. The next one is in the Bermuda Islands, where there's a NASA station. Bermuda will be tracking the launcher from the first Avum ignition to its cutoff on the first pass around the Earth. See how we're going north? You see the composite being spun up before the first ignition of the Avum. The first ignition, a long one, lasting about 8 minutes. There will be another one later on, a short one lasting about 20 seconds. Tell us about some of the other stations. I know there's some stations far north, Norway, Sweden, and Antarctica, that are going to be picking up the signal after the Bermuda station.
Yeah, so we have one telemetry station in Kiruna, Sweden. That is where we upload data for the control of the spacecraft. And then we've got 2 ground stations in...
There's the, while you're thinking, there's the beginning of the first Avum burn.
Okay, one is in Svalbard and the other one is in Troll, and there we download the science data from the spacecraft.
The Troll station in Antarctica will give us the final acquisition of the signal later on. Vega's history, briefly, it's interesting though. She grew out of an early U.S. missile called Scout, you may remember. Italy used the Scout from the 60s through the 80s, and it flew 27 times.
Impressive.
Yeah. Launching originally from Wallops Island off Virginia, sort of on the flight path tonight, north over the east coast of the U.S. Then she launched from the San Marco platform off the coast of Kenya. This was an old oil platform, if you can believe that, on the equator. Kuru is near the equator. In 1992, Scout production was closed down, but the project continued as an Italian venture called the San Marco Scout, led by Ozzy, the Italian Space Agency, and Avio. So you see, Avio has been involved since the beginning.
La télémesure lanceur est bien reçue par la station de Bermude.
DDO says Bermuda is picking up the signal now. Our next film, a look at Aeolus close up.
In August, the European Space Agency will launch its latest Earth Explorer mission, Aeolus. The mission aims to further improve our understanding of winds and help increase the accuracy of weather forecasts. But this new satellite is unlike any other. For example, its shipment to Kourou is by boat rather than plane, because the sudden increase in atmospheric pressure upon landing could damage some of its delicate instruments. Aeolus is also the first space mission to acquire wind profiles on a global scale. This wind data is needed to create weather forecasts.
The end of the project, because we put the laser in the vacuum chamber, and within no time the laser stopped completely working.
So you thought it was the end of the project, everybody panicked. We'll find out what Martin's teams did to fix the situation after the next film on the prime contractor Airbus.
Il reste 2 minutes 30 de poussée de la Vega, mais la propulsion est prête. Le pilotage est calme, tous les paramètres propulsifs sont normaux. Il reste 1 minute de propulsion de la Vega.
So before the Airbus film, you were telling us the project looked like it was off a cliff. What happened? How'd you fix it?
Well, we realized that the difference was ambient or vacuum, and that was the lack of oxygen. So we realized, wait a minute, maybe we need oxygen. We did a few tests, we applied oxygen, and guess what? It worked.
It worked. Now, that was just one of many technical challenges. You mentioned some other ones that you had.
One of the things we had, we invented the in-situ cleaning system to supply oxygen, but no one had built that before, so we needed to find components that could do that. For instance, pressure transducers that work under high-pressure oxygen, but also low-pressure oxygen, did not exist, so that all needed to be developed.
Now, this because the Aeolus being part of the Earth Explorer system, or ESA, Earth Explorer missions always using groundbreaking science, never flown before, so this is part of the, must be very exciting, must be very frustrating.
It's always on the edge of technology. We're always on the boundary of what we can achieve.
The upper stage engine, the Avum, has shut down successfully after its first 8-minute burn. And you see the composite being spun up. Some of the benefits of Aeolus, we've been talking about them a little bit in the films. What's it going to bring to the average person?
But the benefits is that we will have much better weather prediction, so that we can, if there is let's say, high winds or a hurricane or something like this, we can better predict where to put the resources in order to recover the situation.
This mission the 120th satellite built for launching by Arianespace by Airbus. Getting back to them. 20 more Airbus spacecraft remain in the Arianespace manifest.
Phase balistique.
Fifth mission for Arianespace this year. We've flown 3 Ariane 5s and a Soyuz so far. The 299th launch for the Ariane family. Aeolus being the 27th satellite launched by Vega, and the 583rd satellite launched by Arianespace. Some interesting numbers for you. Going back to orbits, our sun-synchronous orbit, most Earth observation satellites have to go into this orbit, heliosynchronous. Why is that?
It's, well, the thing is you want to have a global coverage with Earth observation spacecraft. So then the only way to do it is with a polar orbit.
Because, why, the sun, does the sunlight have anything to do with it?
No, that depends a bit on the mission. For us, for the measurements of the wind, it was necessary to be in the dusk to dawn.
We're going to go now to a replay of the liftoff. You can relive those very exciting moments. You see 3 seconds, and she's gone from the screen, as I mentioned. We have several observation sites across the space here, have cameras at most of them. They record the liftoff from their different angles. It's these shots you're seeing now. Many of the VIPs and invited guests are out there tonight. Have you seen a launch from there?
I just saw last in July the launch of the 4 Galileo spacecrafts.
And how does it compare with the one you just saw?
Yeah, completely different. I mean, the Ariane is much larger and slower, but the sound is more intense.
Yeah. And the sound from the launch base takes about 90 seconds to come here to where we are in Jupiter. Is it the same for the Vega? Because I've never seen...
No, it's less of a delay between what you see and what you hear.
Does that have anything to do with the Doppler effect that you're going to talk about?
No, it's mainly the distance.
I'm confusing two things. Well, I'm no physicist. All right. Over the fine shots of the replay, we're going to say a temporary goodbye. We're going to cut away for about 20 minutes while Vega enters a ballistic phase, waiting for the second AVM ignition and the end of the mission after that. So enjoy the break. We'll be back at about plus 21 minutes. See you then.
Great. Thank you for coming back to join us. We're still out on the terrace.
Si je parle, homme-là, fidèle au rendez-vous, à plus 41 minutes et 20 secondes.
41.22 seconds.
Vega a décollé il y a plus de 40 minutes. Et le sujet, bien, tout de suite, c'est avec
And
Alexandre
the
Dallonneau qui nous explique.
upcoming film that we're going to show you is a review of flight events.
We are now in the ballistic phase. To get us here, you saw that we lifted off on time 41 minutes ago. After liftoff, Vega's first stage, called the PAT, burned for just under 2 minutes, taking the launcher to 53 kilometers altitude. 1 second after its separation, the second stage, the Zefiro 23, took over burning for 1 minute and 40 seconds. When its engine finished burning, Vega was at 127 kilometers altitude. 40 seconds after, the Zefiro 9, the third stage, took over. Its engine burned for 2 minutes and 40 seconds, taking Vega to 213 kilometers when it separated. Its pitch on separation is normal because it allows Earth to better control the thrust. We are now at 6 minutes and 30 seconds after liftoff. A short ballistic phase of 90 seconds followed before the first AVUM ignition. Our speed, it was 7.3 kilometers per second. The first AVUM burn lasted 8.5 minutes. At the end of this burn, Vega was flying at 350 kilometers altitude. When then entered the ballistic phase, which latest for 36.5 minutes. The long ballistic phase will end at H plus 53 minutes. The AVUM will be at 320 kilometers altitude. The second AVUM burn will circle Vega's orbit. It's a short, only 20 seconds roughly. Aeolus will separate from the AVUM at H plus 54 minutes and 57 seconds. Because of spacecraft mission specificities and its atmospheric laser Doppler instruments, Vega's trajectories was constrained in attitude throughout the flight, making it a complex mission. Vega is designed for such constraints, making it the perfect launch system for this kind of mission.
Thank you to Alexandre Dallonneau for this recapitulation of the mission. I'm still on the terrace, still seeing the setting suns. There are a few clouds and some red glow. We're going back to Jupiter with Josh.
We're still here on the inside. With me now, Joseph Aschbacher of ESA, the director of the Earth Observation Programs. Welcome.
Thank you.
We have 3 questions for you. First question, what are the Earth Explorers? Que sont les Earth Explorers?
Earth Explorers are one series of satellites which are dedicated to science. In fact, they are serving 2 purposes and are driven by 2 main objectives. One is to answer burning questions of science, and secondly, to explore new technology which has not been flown before and which is completely new. And Aeolus is the 5th of the Earth Explorers. We have already launched 4 of them.
Some of them here on the screen.
They're here on the screen, Goche, SMOS, Cryosat, and Swarm. So now the 5th one is Aeolus, and we keep still our fingers crossed that all goes perfectly well. But we also have some others in the pipeline, like Biomass, Flex, EarthCare, which are the next ones to be launched. So they're really addressing questions of science to better understand the Earth system as a whole.
How does Aeolus fit in globally to the ESA Earth Observation Programs? Quel est le rôle de Aeolus dans les programmes de l'observation de la Terre de l'ESA?
Aeolus is one of 25 missions which are under development in the Earth Observation Program. In addition, we have 14 missions in operation. So really we have a very strong portfolio of different missions, different satellites, either in development or in operation. So Aeolus is really the mission addressing very important questions which are relevant to society, better weather forecasts, better weather prediction, but also climate modeling is a key application. And it really is one element of a larger family, a larger group of satellites that do measure various parameters. I should say that the Earth Explorer family is the research mission, while we have also other families which are more geared towards operation, the Copernicus missions and meteorological missions.
Okay, how about the Sentinel missions? How does Aeolus fit into the Sentinel missions? Quel est le lien entre Aeolus et les missions Sentinel de l'ESA?
The Sentinel missions is a different type, different family of missions. They are operational missions. We are doing them with the European Union together. They are co-funded. The space component is co-funded by the European Commission and the European Space Agency. But they are really serving policy priorities of Europe, which are addressed with different parameters. We have launched today 7 out of the 20 Sentinels that are funded currently. And they really build up, I would call it the world's best, most ambitious Earth-observing system. I should also mention that in addition to the Sentinels, we have meteorological missions, which we are doing together with EUMETSAT, and we have the honor of having Alain Ratier with us today. We're also working, ESA and EUMETSAT, extremely well together in order to build geostationary and polar orbiting missions.
Okay, we're out of time. Josef Aschbacher from ESA. Many thanks.
Thank you very much.
We're going to go to a film now. What have we been talking about? The winds and the weather. We have a film on just that coming up. We'll be back with more and the end of the mission and satellite separation. Don't go away.
Winds on our planet are created by the difference in temperature between the equatorial regions and the poles. They are the flow of air from high to low pressure. As warm air rises in the tropics, it flows towards the poles, where the air pressure is lower. On its way there, the air cools and sinks again, conversely leading to higher pressure and counterflows near the surface. This way, winds are basically redistributing heat energy over our planet. This process of energy redistribution, combined with the Earth's rotation, generates the weather patterns we experience every day and makes our planet habitable.
If we didn't have any winds in the atmosphere, then it would be very, very hot in the tropical regions and very, very cold in the northern regions. We would not be able to live in Europe because wind is a very effective transport of energy. It's similar to the draft in your house. When you open a window, you get flow in and change the temperature in the house. The wind have the same effect for the circulation. So that's the main reason for the wind.
Since the dawn of time, mankind has been trying to assess winds and predict the weather. Where in ancient times farmers had to consult soothsayers and oracles, today we have more modern ways of predicting the weather. This is the European Centre for Medium-Range Weather Forecasts in Reading, UK, a partner of ESA in the Aeolus programme. They make global numerical weather predictions based on in-situ and satellite measurements. Their forecasts include detailed weather predictions within the next 2 weeks, less detailed forecasts for the next month, and indications of likely trends up to a year ahead. These numerical predictions are the basis for weather reports worldwide, and they are important for society.
The reason why it's important for society is probably the most important reason is it can save lives because occasionally the weather is extreme. If we have extreme storms, and it's very important that we warn people about this in advance. So the more accurate we can make our forecasts, the earlier we can advise people to take action to avoid being involved in weather disasters.
In order to run weather models based on numerical weather prediction, it is important to have sufficient and accurate data on the current state of the atmosphere, such as global wind and temperature, as it is their interaction which drives our weather. Today, this data is mainly obtained via in-situ measurements of weather balloons, ground stations, and data from aeroplanes. Satellites are used to measure temperatures from space and track winds indirectly through cloud movement and wave movement on the ocean surface. However, there remains a significant gap in wind data over vast land areas, the oceans, and especially between the altitudes of 10 to 30 kilometers, where there is no in-situ data available.
So we need to know the winds in remote areas such as the oceans because those winds in those areas determine what the weather will be downstream in, for example, over well-populated areas such as Europe many days later.
To address this need for more accurate global wind profiles, ESA will soon launch the Aeolus Earth Explorer satellite, with the ECMWF processing the data. If Aeolus can deliver the long-awaited wind data, meteorologists hope more satellites like Aeolus will be launched in the future. For numerical weather forecasts, it's important to have accurate wind measurements today to predict the weather tomorrow.
We have been picked up, or we're going momentarily to be picked up by the New Norcia. Am I saying that right? New Norcia?
Yeah.
Station in Australia, not far from where Aeolus is going to be separated, by the way. She's going to be separated off the coast of Australia, I do believe.
Acquisition de la télémesure lanceur par la station de New Norcia.
And the DDO has just announced that the signal has been picked up there. Now, just a word about the space base. The French chose the French Guiana site when they wanted to build a new site in 1964. There were many possibilities, including Australia and Scandinavia. Kourou got the nod because it got a lot of advantages. A large opening on the ocean, a low population density, nearness to the equator, and nearby hills where you can put installations for radar and telemetry. And you're looking at shots of the nearby hill where the CVI, also called the Real-Time Visual Center, is located right here. There's a lot going on there. These buildings are located just behind us here in Jupiter, in Kourou. And the hill is called the Montagne des Pères, the Mountain of the Fathers. Now, these teams are analyzing the data as it comes in from all the ground stations along Vega's flight path. Remember, we've been talking about Saint-Hubert and the Bermuda Islands and all the rest. These data are then treated to reconstitute the entire mission. And after that, the entire flight is recreated in figures from liftoff to well after satellite separation, then analyzed again in delayed time. So all that to say that Arianespace has a huge amount of information in its archives. How each launcher, going back to the first Ariane 1, Christmas Eve 1979, remember, has performed. The first UV laser. That's something that you wanted to talk about. Now, what is that? That's part of the light of the Doppler?
Yeah, exactly. We are the first spacecraft that brings its own light source in orbit.
Okay. The DDO has just called out the second ignition of the Alum fourth stage. That's going to last for 20 seconds. Go ahead, sorry.
So it's also something that Anders Elving, the project manager, has said in one of his videos, is that we are the first spacecraft to bring a light source on board. That's not done before. And it's quite unique in the sense that we emit our own light.
And the DDO has just called it the extinction of the second burn?
Okay, good. So we have our own light source, we emit and receive.
Manœuvre d'orientation avant le boost RAX.
Oh, sorry, I thought I had to wait. So, and this is a first. So all the other agencies and programs have tried it, and they stopped because of all kinds of difficulties, because the laser is so powerful that you get all kinds of issues.
We are coming up on separation in under a minute. Can I ask you what's going through your mind now? Are you as emotional as you were at liftoff?
Well, this is going to be the moment that Aeolus will stand on its own to become an adult and go to work.
She's already an adult if she's 20 years old.
Yes, a young adult.
Yeah, or an old adolescent.
Yes.
All right, so you're feeling good.
We're feeling good. Yeah. We're feeling still a bit emotional, and it's quite strange, the feeling, and looking forward to the solar array deployment later on.
All right, this is, for Martin as for all of us, a moment of high concentration here in Jupiter and, of course, elsewhere around the world for the Aeolus people as we await separation. Everyone be focused. We've gone through separations before, but it's never quite...
Et séparation Aeolus.
Now there's the scheduled separation. You hear the applause, and you see the people smiling. That's the scheduled separation. Looks good. Assuming we're going to have to wait until confirmation, of course, when we get the signal from the Troll station in Antarctica, but let's assume that all is well. So congratulations.
Thank you, Joshua.
Your work is just beginning, or is it over now?
In essence, it should be over now, because it's being taken over by our colleagues in ESOC. If they need me, it means that they have an onboard problem. So let's hope.
So that they don't call you.
Exactly.
Okay. We are waiting for confirmation, as I mentioned, confirmation of the acquisition of the signal from the Troll ground station in Antarctica. We want to wait for full confirmation just to see if separation has occurred properly, that Aeolus has been sent on its proper orbit, that its solar arrays are going to be in a position to be properly deployed, that the satellite's overall health is good. A few important items, I imagine, that you have to check before we can let the satellite officially start its life and work area in space, and ESA, of course, taking no chances, being very thorough. While we're waiting for the information to come in, here is another play. There will be a third avant burn, which is usually the case. We won't see it. It'll be in about 2 minutes. It'll be of about 2 minutes, I should say. It'll be for passivation. You know about passivation? That's when it takes place at a much higher altitude, and the what's left in the fuel of the upper stage tanks are emptied. So the satellite poses no danger to anything. That's another avant burn to put it into a slot there. But again, we won't see that. And also looking ahead, there will be a first post-flight analysis of the mission. We mentioned the archives that Arianespace has. That'll be held in the afternoon at the CVI, the Real-Time Visibility Center we saw earlier. There will be a technical review and a final post-flight review. On the phone enters